All right, good morning. Let's go ahead and take a look at 5.1. I know that that's what the video of our friend talked with you about yesterday, and you already did a homework assignment on page 225. We can do a couple of those problems. But I want to do a few notes. So what I'm getting ready to write down here, I'd like for you to make sure you write into your notes and you follow along. What makes a triangle congruent? This is pretty much review for us. We know what this means. Corresponding parts of a congruent figures are congruent. We spent a lot of time talking about that. In fact, that was actually one of the answers on the test. Okay, well, all we do is we kind of make the transition that corresponding parts of congruent, instead of figures, we just call them triangles, are congruent. Corresponding parts of congruent triangles are congruent. And just as we've talked about before, there are 6 parts, in that there are 3 angles and 3 sides. And if you can show that all 3 angles and all 3 sides are congruent, then you can then safely determine and conclude that the 2 triangles are congruent. Okay? And so, with that being said, let's take a look at a couple things. I know he went all the way through yesterday. Your turn number 3, I believe, is how far he got, if I remember right. But turn to page in the book on page 222. We're going to look at your turn number 5. Okay. So if you look at that, it has 2 angles that look like this. I'm just going to throw the numbers in there so you can see them: 41, 79, and 60. And then it's got 60, 78, and 42. Well, immediately you should see that they do not have the same angle measures. Now 60 and 60 do, but 41 and 42 are not the same, 79. So these triangles are not congruent. And that's what we would say in determining whether or not they are arcs. Okay, so what about how they're named? So now if we say that they're congruent, so let's just say that triangle ABC is congruent to triangle DEF. Without looking at a picture, remember that everything has to match up. Everything has to match up. The A and D would have to be congruent. That B and E would have to be congruent. And also C and F would have to be congruent. Okay. So and then also AB would have to be congruent to DE. I know we've done this, but all the different sides would have to be. And you can tell that just from the congruence statement. That's what this is called, the congruence statement. Okay. All right, so going back to the book then, let's take a look at a couple of examples. Let's take a look at example B, which is on page 223. Example B, page 223. And it says, we've got a picture, looks like they got one upside down. This is 50, this is 36, this is 30, and then we've got this is 30, this is 50, and then we got 2y plus 20. And we've got some arcs here, 1, 2, 1, 2. And we've got arcs here. Alright, so clearly we can determine which angles are congruent by the arcs. And so if you're filling in the blanks in the book, sorry, John. Filling in the blanks in the book, it says angle A is congruent to angle D. And you can see that because there's a single arc. So A is congruent to D. And we know that B is congruent to E because I guess that has 3 of them, doesn't it? 3 of them. So B is congruent to E. And then the only one that's left over, of course, would be C and F. So those angles are congruent. So DE corresponds to AB. This is very important. DE corresponds to AB. That means they have to be congruent. So DE, which is 2y plus 20, has to be equal to AB, which is 36. Now I can solve for y. Okay, so I'm gonna subtract 20 from both sides. So I have 2y then is equal to 16, and then y is equal to 8. And I have solved what they wanted me to find, the value of the variable that makes those parts congruent. Okay, let's go to a couple problems on the homework. We had to go all the way, I think, through 14, if I remember right. Yeah, 2 through 14. So let's take a look at, let's see. Let's go to number 13 first. All right. Let me get a sheet of paper. I'll flip this one over. So number 13 says directions are determine whether the given triangles are congruent. All right, so we're going to take a look at these two triangles. You have the graph there, and we know that we have two right angles. I'm not going to redraw the picture because you can look in the book. Angle B is equal to 90, and angle E is equal to 90. So we know that those are congruent. Then we know that angle A is equal to 33.7. Can you guys see that okay? Is that showing up all right? Not too bad. Angle A is equal to 33.7. Let me focus down a little bit. 33.7, okay? And then we know that angle F is equal to 56.3. Well, because we know that all the angles add up in a triangle, they add up to 180 degrees, then if this is 90 and 33.7, that means angle C has to be 90 minus this, which is 56.3, which, look at that, it matches up with angle F. If this is 90 and this is 56.3, then that means that angle D would have to be 33.7. So we know that all three angles are equal. All right, so now that's one part of it. But however, look at this. Now some people would say, well, isn't that enough? Well, no, it's not. Because watch, what if I draw a triangle? Let's call it an equilateral triangle, so it's not the same as equiangular, equiangular triangle. So equilateral, there we go. Can everyone see that all right? Can you see that on the screen? Let's make sure. Yeah, not too bad. Okay, you see it? Well, what if I just do a bigger equilateral triangle? Everyone see that? Now I've got a equilateral triangle here and an equilateral triangle. They have the same angle. Are these two triangles, are they congruent? No, not at all. Just because the angle measures are equal, that doesn't mean that the triangles are congruent. And clearly you can see that the sides are not the same length. That makes sense? And so if the angles are congruent, that's not enough to say. So what we also have to show on 13 is that the sides are congruent. So we've got the angles, we've got three parts, now we've got to show the sides. Okay, so, all right, well, that can be kind of challenging on a problem like this. But, you really just have to use the distance formula quite a bit to see. Okay, and so what I'm going to do is I'm going to put the coordinates of all 6 points, and then we're going to do the distance formula. All right, so here we go. All right, so we got A, B, and C. Let's make sure I'm copying it down. There we go. A is what? -3, +1. And B is 0, -2. And C is -2, -4. All right. And then we've got D, E, and F. D, E, and F. Okay, so D coordinate is 3, 4. E coordinate is 0, 0. That helps. And F coordinate is -2. Wait a minute. What's the coordinate of 4? That looks like a D. That looks like it's 3, 3, not 3, 4. All right, so let's be careful there. All right, so yeah, I think that's 3, 3. Okay. And then f is negative 2, positive 2. The book, if you look at the book, they've got the number wrong. I don't know if you guys see that or not. Let me get the book out and show you. We'll find a lot of mistakes in this book. It looks like we just found another one. Alright, so 224. 227, I guess it is. No. Yeah. See, can you guys see that? Let's go in. Yeah, you can see it. See that 4 right there? That's only 3 digits up. 1, 2, 3. 4 there. Problem. Okay, well. Alright, so we caught it though before we got any further. Alright, so now what we're going to do is we're going to find the distance of all 3 sides. Okay, so we're going to use the distance formula. That's why I put it on canvas. Alright? So we're going to find the distance formula between AB. It's the square root of. Do you guys remember it? Let's write it up here so we have it. Okay, so there's the distance formula, find the length of each side. Okay, so now we go the x's, so negative 3 minus 0 squared, and then the y is 1 minus negative 2. Make sure I'm on the screen. Yeah, we're good. Okay, so negative 3 minus 0 is negative 3. Negative 3 squared is 9. Negative 1 minus 2 is 3. 3 squared is 9. And so we have the square root of 18. Let's just leave it like that. Okay, so we know that AB is the square root of 18. All right, now let's go BC. All right, so 0, do the x's. 0 minus a negative 2 squared. Negative 2 minus negative 4 squared. So here we have 2 squared, which is 4. And negative 2 plus a positive 4 is 2 squared, which is 4. And so we have a square root of 8. All right, now let's do AC. AC, we have got negative 3 minus a negative 2 squared, and then 1 minus negative 4 squared. Negative 3 plus 2 would be negative 1. Negative 1 squared is 1. 1 minus negative 4 is 4 squared, which is 5. 5 squared is 25. So it looks like we're going to have the square root of 26. All right, so there's our 3 lengths on this triangle. Now, in order for us to prove that these triangles are congruent, we also have to show that the length of these have the same length. So let's go DE first. Let me make sure you can see it. DE. Let me move it over just a little bit. Okay, there we go. All right, so we have 3 minus 0 quantity squared plus 3 minus 0 quantity squared. 9 plus 9. Aha, look at that, 18. So DE and AB match up. Okay, so if I'm thinking of a congruent statement, I have ABC, and I know that AB and DE match up. So it should look something like this. Okay. All right, well, let's do the other. We gotta do 6 parts, right? So DE, so let's do BC, let's do EF. All right, so EF, distance formula, 0 minus a negative 2 squared plus 0 minus 2 squared. Be careful with your negatives. That'd be positive 2. Positive 2 squared is 4. Minus 2 squared is 4. So we have the square root of 8. Ah, look at that. It does work. So B, C, and E, F are the same. We got one more to show, and we are done with number 13. So we're going to go DF. So we're going to go 3 minus the negative 2 squared, and then 3 minus 2 squared. We got the square root. Just on the screen here. There we go. 3 minus 2 is 5. 5 squared is 25. 3 minus 2 is 1. So 1 squared is 1. And so we have DF is equal to the square root of 26. Look at that. So number 13, we would say, therefore, all 6 parts of the triangles are congruent. So therefore, corresponding parts of your triangles are congruent. Okay. All right, so you get the idea. So there's number 13. That's how we do these problems on the homework. So there's no new assignment. Just wanted you to hear me teach this. And it looks like, according to the announcements, we'll see you on Monday. Hope you guys all have a safe and good weekend. If you have any questions, just email me. If you haven't taken your quiz, you need to take the quiz. You need to touch base with me, and let's figure out a time when we can get that. All right, take care. Thanks.